So we talked a little bit yesterday about where we were going with this today, but so far we have the law of sines to help us solve oblique triangles, but that really only gives us tools to solve triangles with two angles and a side in any order, or two sides and an excluded angle. Okay. Well, what happens? How do we solve a triangle if we have three sides or two sides and an included angle? Okay. So that's what we're going to use. That's what we're going to use the law of cosines to help us with. Last week you went through that blue sheet to get to the law of cosines formula. You've also worked with it before, but in the most recent past, on Friday, you went through that worksheet. Or was it Thursday? Thursday, I think it was. That's the day it was called. So you know that the law of cosines formula is a little bit more intricate than the law of sines formula. It might take a little bit more brain power to remember the law of cosines formula. Now, I don't think it is necessary for you to write all three of these down because they're all the same. They're just using different sides and angles. If you know one, you can rearrange it to get to the other two. I don't care what you decide, but at least write one of them down. When you're done writing, I will talk about how I like to remember how they're set up, and then we'll talk about when we can use them. So when we are presented with the given information of side angle side or side side side, we can use the law of cosines to solve our triangle. Okay? And what happens, notice how it incorporates all three sides, which is why we have to have at least two in order to be able to use it. Okay? So we have side squared equals side squared plus side squared minus 2 times these same two sides times the cosine of the angle that matches this loner side on the other side of the equal sign. Okay? So I want you to notice that this side matches this angle, and then these sides match right here. Okay? So if you know one version, you should be able to rearrange it to get to the other versions, which is why if you have one, you wouldn't necessarily need to write all of them down. It's a little bit more intricate. There's a little bit more algebra that we're going to have to worry about when we go ahead and solve these. So today I want to make sure that we are careful with how to use these formulas. Okay. If you don't already, please have your calculator out so we can practice using our calculator. Okay, I know that some of you really like to work ahead. That's great. Today's not a day to do that. Today's a day that you need to stay with me on the problem. I have some tips for you on your calculator. There's some algebra that I don't want you to mess up on and miss something that I hear. So please stay with me during our examples. Okay. So here's our first example. We have angle A is 55 degrees, B is 3, C is 10. Go ahead and write that information down, and then if you want to draw your triangles so that we are ready. So I want you to notice in our picture, yes, we are given two sides, but do you see how this time the angle is sandwiched between the two sides? Okay, that is what we call side angle side. When our angle is not sandwiched in between, we have the ambiguous case. That's not what we have. We have SAS here in this example. Okay. Along with some of you. Ethan, I think. Okay, so we can use the law of cosines. Since the law of cosines involves all three sides, what do we have to solve for first? Side A. All right, so this is what we're going to do. A squared equals B squared plus C squared minus 2 times times B times C times the cosine of the angle that matches our lower side. Now, don't do it yet, but do you notice how all of these are numeric values? So we could type this into our calculator and get a number, right? A squared is going to equal that number. So what are we going to have to do to both sides? Okay, in order to get just A, we are going to have to square root both sides, okay? I'm all about being efficient with my time. You have a very nice calculator that you can see what you are typing in and go and change things and fix things. There is no need to do one little calculation at a time, okay? We can type this in all at once, okay? We can type in the square root of 3 squared plus 10 squared minus 2 times 3 times 10 times the cosine of 55. That needs to be a minus sign, not a negative sign. Yes, there is a difference between minus and negative. Make sure this is subtraction. Okay. So we get side A to be 8.64. Now we have side A. All right. Now what do you want to solve for? Angle B. Grace, how would you like to solve for angle B?
Sine A.
Why is she pulling out the law of sines right now? Can we do that? You said yeah.
Okay.
Why? Why?
It's still a triangle. It's still a triangle.
Oh, we have the necessary information to be able to use the law of sines. Is that true? Do we have a side, and an angle? To where when we pair them up, okay. Stop typing things in your calculator and stop writing things down. Yes, you are allowed to switch to the law of sines. And I have no problem with that. However, you have to be careful. Do you remember how we had the ambiguous case yesterday? Okay. Our calculator, when we type in inverse sine, does not give us an obtuse angle. It always gives us an acute angle. And that's why we had issues with our ambiguous case yesterday. Okay? Now, how many solutions are we going to have to this triangle? One and only one. There's no question about it. Because it's side angle side. It is not the ambiguous case. We will only have one solution. Okay? So if you switch to the law of sines, you need to be careful, and you need to make sure that you are not solving for the biggest angle with the law of sines. Okay? In the case that we have an obtuse angle, you're not going to get that with the law of sines. Okay? So let's look at our picture. What angle is the biggest? I'm not going to use the law of sines to find C. We should instead solve for B. So it is fine to switch. But we just have to be smart about it. So yes, it is fine to say the sine of B over 3 equals the sine of A over A. So please help me out. In your calculator, multiply this 3 over, and then since we're solving for the angle, you need to take the inverse sine of whatever that number is. Great.
Why did you say you couldn't do C again?
Well, it is possible, we don't know, but it's possible C could be obtuse. And if it is obtuse, inverse sine is not going to give us that.
Oh, because it only goes from pi over 2 to
Yes.
Gotcha.
So, if we stick to the law of cosines, it wouldn't matter which one we solved for first. But if you want to make the switch to the law of sines, you have to be careful.
How could you go about using cosines?
You just keep using the law of cosines. So we could have set up, like if we wanted to solve for B using the law of cosines, we could have said, let's see, B squared equals A squared plus C squared minus 2 times A times C times the cosine of B. And then we solve for B that way. Okay? Which one is going to take less work? Probably the law of sines way, which is why I have people wanting to switch. I don't care what you do as long as you're careful. All right? Ethan, what do you get when you switch, when you do the inverse sine of all of that?
16.52.
5.2? Like you went around it to 5.3?
No.
Okay. Okay. And now we have two angles, right? And so 55 degrees plus 16.52 degrees, subtract it all from 180. Okay, good thing that we found angle B first, because we would have not gotten 108 with our inverse sine. Okay. What can I clarify for you on this? Yes. When we do the ambiguous case, we have one solution. We find the only angle we can, and then we potentially have a second triangle. Yes, it's the first angle that you find. You do the supplementation. Yes, yes. Now here, there's only one answer for B and one answer for C. And so if we try to find the biggest angle, we don't know if it's going to be the acute or the obtuse angle, which is why I'm telling you to just avoid doing that. Okay? All right, let's look at a side, side, side case. There's a quiz. Yes. There's a quiz this Thursday and next Thursday. Your quiz next Thursday will determine how much homework you have over break.
So like if you fail, you have a lot, and if you do good, you have a little.
I know. Okay. All right. Now, we have all three sides. So first of all, since we have side, 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 we know that we can use the law of cosines to solve our triangle. And much like before, as long as we find it once and then move on, we can switch. But we have to start with the law of cosines. Now, knowing what we do from our last example, if we want to make the switch to the law of sines, what angle would we maybe want to find first using the law of cosines? Why A? Because it's the biggest side, right? If we find angle A, it's the biggest angle. We don't have to worry about which angle we find with the law of sines. Okay, we're not going to have an issue. Okay, so I would suggest in a side, side, side case, when you're using the law of cosines, find the biggest angle. That way, if you decide to switch, it's not a problem. So let's set that up to find angle A. So A squared equals B squared plus C squared minus A, nope, that's a 2. 2 times B times C times the cosine of A. Please don't get ahead of me. There is some algebra that we really need to work through together. Okay?
Do we have to memorize this?
Yes. Which numbers can I subtract over? 20 squared and 18 squared. So please, in your calculator, take 34 squared minus 20 squared minus 18 squared. What's that number? 432. And that equals minus 2 times 20 times 18 times cosine A. What is minus 2 times 20 times 18? 700 what? We subtracted these numbers, but these that I'm highlighting in green are attached to cosine A by multiplication. So instead, we're going to need to divide those over. So the cosine of A equals 432 over negative 720. So in order to figure out what angle A is inside of cosine, so what are you typing in your calculator? Inverse cosine of 432 over negative 720.
Oh.
Glad I can answer your question.
Could we not have manipulated the equation?
You could. Yeah, and if you're more comfortable with that, go for it. Okay, Grace asked, could I have manipulated the equation first and then plugged in my numbers? If that's more comfortable for you, you go for it. Okay? What is angle A? $126.87 degrees. Awesome. Who is not getting that in their calculator and needs some assistance?
I just
You
did
inverse
that.
that. Since it's cosine of A, you want inverse cosine. Do you understand what I mean?
Yeah,
Okay.
I'm just being dumb.
No, that word's not allowed in the classroom.
I was being silly.
I failed to see that small detail. Okay, so do you understand what I mean when I say that the law of cosines formula is just a little bit more intricate, right? We have to be a little bit more careful. So if you don't feel like doing this 2 times to find 2 of your 3 angles, I understand. Okay? At this point, now that we know angle A, we have enough information to use the law of sines to help us with the rest. And since we have found our obtuse angle, we don't have to worry about which angle we're finding. Okay? Max, which angle do you want to find next? There's no wrong answer. What do you say? B. So if we wanted to solve for angle B, we would set up the sine of B over 20 equals the sine of 126.87 over 34. Now that we're using sine of B, multiply this 20 over, and now you're going to use the inverse side to solve for that angle. Mary, what'd you get? 28.07 degrees. All right, and then what's left over for angle C? 3, yeah. What's left over? 25.06 degrees. Okay. Now, did anybody take it upon themselves to stick with the law of cosines to find angle B? Okay, I was just curious. So, it is possible that, like, since we're using rounded answers, we could differ in answers by maybe like 100. Okay? So don't be surprised if that happens with like your work and my work. Okay, if you use a different, thank you. If you use a different method and we're using rounded answers, we could differ just like. Okay? Okay, so if I give you any triangle besides angle, you should be able to solve it. Yes? Okay, you need to practice it, but we have all the tools we need to solve it. Okay? One more formula that I'd like to talk to you about. On Friday, we talked about our law of sines area formula, 1/2 times side times the sine of the angle in between. Okay? I know for a fact that you looked at this formula in Algebra 2, but we have an area formula if we are given all 3 sides. Okay? You know all 3 sides of a triangle, you can plug into this formula and find the area without knowing a height, without knowing an angle. It takes care of all of the geometry for you. I'll go ahead and have you write it down, and then we will go through an example together. Okay. Yes, it's like 1. I don't know why our book calls area capital S. I think it's silly, but that's the big S that you see. So if you'd rather write area equals as opposed to big S equals, I would be fine with that.
What does little s?
Little s is this right here. So it's like a 2-part formula. You need to calculate this so you can plug it into that big square root diagram. It's really not bad though, because a plus b plus c times 1/2. That's a number that in our square root we say that number times that number minus side times that number minus side times that number minus side. So really, like right now your eyes are like, well. So let's find the area of this triangle. Sides are 43, 89, and 120. So first we're going to calculate little s. We're going to add these 3 sides together and divide by 2. So if you could do that for me, please, I would appreciate it. Paige, what's little s? 126. Okay, so really not very strenuous. It's more just a lot of typing. We're going to take the square root of 126 times 126 minus 43 times 126 minus 89 times 126 minus 120. Okay? And guys, don't spend time actually figuring out what each of these numbers are. Just type it in like you see it. You have parentheses. You have all of those buttons. Just say square root 126, parentheses, 126 minus 120, parentheses. Yada, yada, yada. Type it in like you see it. Don't give yourself an opportunity to make a mistake by trying to do things individually and then typing it in. Okay? Type it in like you see it.
Dude, in our calculator, do like the 3 parentheses need to be in 2 big parentheses? Or no?
No.
No.
Because everything is being multiplied,
Okay.
and so a parentheses would assume that multiplication.
Okay.
Grace P, what do we get?
1,123
Point.
seconds.
Like that? Square units. I don't know what the units are, but it's square units because we're talking about area. So we are gonna have a quiz on Thursday. Tomorrow we're gonna do some work of using all of the formulas together. You'll walk out of here with a review, but in class, we are going to watch a small clip of Star Wars. I can't remember. I mean, like
45 minutes.
like 7-8 minutes. And I'm going to give you a map. Okay, so we're going to watch the pod racing scene is what we're going to watch. And I'm going to give you a map of the race. And we're going to actually find different distances of where they race. Okay? But before we do that, we get to like take a break and watch Star Wars for 7 minutes. Okay? So that's our day tomorrow.